Hello, in this video we have a nice equation 3 to the power of x is equal to x to the power of 3. What is x? If you have a quick look at this equation, you would probably say x is equal to 3. Yes, you are right. 3 is at least one of the solutions of this equation. The million-dollar question is 3 the only solution of this equation? So first of all, let's look at the range of x. 3 to the power of x is always positive. So x to the power of 3 is positive. X is positive. Then let's look at the graph of the functions on the both sides of this equation. 3 to the power of x, x to the power of 3. So here's the graph of these two functions. The black line is 3 to the power of x. The red line is x to the power of 3. So it seems like there is intersection here. Unfortunately, it is not clear how many intersections in this area. Let's zoom in and we get the right side figure. So it clearly shows that there are two intersections of the two functions. So one is 3, the other is right here. So it seems like 2 point something. So we are going to figure out this value. Let's go back to the original equation. So we take the natural log of both sides. Then we get ln 3 to the power of x is equal to ln to x to the power of 3. Then we apply the rule ln a to the power of b is equal to b times ln a. Then this equation goes to x times ln 3 is equal to 3 times ln x. Then we move 3 to the left side and x to the right side. We have ln 3 over 3 is equal to ln x over x. So we're going to have a deep look at this equation. We let fx, a function, is equal to ln x over x. Then we differentiate this equation, this function. We have the derivative of fx is equal to 1 over x times x minus ln x over x squared is equal to 1 minus ln x over x squared. So we get the original equation and we have fx here and the derivative of fx. So let's look at the feature of this function. When x is equal to e, the derivative of fx is equal to 0, fx is equal to 1 over e. When x is greater than 0 and less than e, the derivative of fx is positive. Fx increase in this range. When x is greater than e, the derivative of x is negative. Fx decrease in this range. So we got an idea of the graph of this function. That is, when x is equal to e, fx is equal to 1 over e is a local maximum value. So let's directly bring up the graph of the function. So here is the graph of fx is equal to ln x over x. So as we described, when x is equal to e and there is a local maximum value, and we have 3 is one of the solutions of the original equation, and f3 is equal to ln 3 over 3. So as the straight line, so this straight line as ln 3 over 3 has one intersection, that is as x is equal to 3, and the other intersection is the corresponding x is the other solution of the original equation. So this value the other solution is less than E, so E is equal to 2.718 something, so it's less than E, and it's looks like 2 point something. So we're going to figure out this value. So again, we go back to the original equation. So let's take the power of 1 over 3 for both sides. We have 3 to the power of x over 3 is equal to x. Then we divide both sides by 3 to the power of x over 3. We have x over 3 to the power of x over 3 is equal to 1. Then make an arrangement. We have x times 3 to the power of negative x over 3 is equal to 1. So, 3 is equal to e to the power of ln3. So we place 3 with this value. We have x times e to the power of negative x over 3 times ln3 is equal to 1. Then we multiply both sides with negative ln3 over 3. Then we have this equation. So we times both sides with negative ln3 over 3. So up to this point, you may be asking why you are complicating this equation. Because we have to use Lambert's W function to get the value of x. So I'm not going into details for this Lambert's W function. You can simply take it as the inverse function of x times e to the power of x. So if y is equal to x times e to the power of x, so the number W function of y is equal to x. So we describe this function as WA times e to the power of a is equal to a. So it is the inverse function of a times e to the power of a. For example, WE is equal to 1, W0 is equal to 0. So in our case, look at this equation, a times e to the power of a, so a is equal to this part. A is equal to this part. Negative ln3 over 3 times x, so a is equal to this part, and a times e to the power of a is equal to this value. So a times e to the power of a is equal to negative ln3 over 3. So we use calculator and we get this value, negative 0.3662. So the question is, what is WA e to the power of a? So that's also the value of a. So we want to get the value of a, and then we can have the value of x. So here we directly bring up the Lambert's W function calculator. So right here, if we put the arguments, the value of arguments, the x is equal to negative 0.3662, and we click compute, we get two values of the function. So that is a is equal to negative 1.09873 or negative 0.90763. So with this, remember we have a is equal to ln3 over 3x. So negative ln3 over 3x is equal to these two values. Also, remember we have negative ln3 over 3, so we use calculator, we get this value. So we have this equation. Then we have the value of x is equal to 2.47752 or 3. So this is 3. We already know this solution, and the other solution is 2.47752. With this, I would close this video. Thanks for watching. I appreciate if you can subscribe to this channel for more videos. I will see you in the next video. Thanks, bye.